Hey everyone, in this video I'll be talking about composite functions and basically just going through the conditions required for a composite function and also what will happen when you get a composite function. If you recall in the introductory video, we kind of briefly mentioned this, but let's say if we have a function of fx equals to x plus 3, and if we were to have f bracket x squared plus 2, we are basically substituting every x with the new function x squared plus 2, therefore getting a new function of x squared plus 5. The idea is that in a composite function, from the name, you're gonna be basically having more than one function to give you just one function. So if you to let gx equals to x squared plus 2, we have f gx, right? F bracket gx bracket x to give us fg whole thing, then bracket x. Now there are conditions that you need to satisfy for a composite function to exist. Alright, the first being, actually the only one, is that it's actually pretty intuitive. The range of G must be a subset if not equals to the domain of f. Why is this so? If you look at the function f gx, right, which is basically f bracket gx, your gx is now the input, and the value of gx is basically the range of g, and your input for f, which is basically the domain of f. As such, the range of g must be part of the original domain of f, otherwise you'll get values in the range of g that will not satisfy or will not give a valid fx value. Okay, for example, let's say we have fx equals to same function, right? Let's say x plus 3, and let's restrict the domain to x between 2 and 4 inclusive. Now from here, right, we know that the range of f is simply 5 to 7 inclusive. The idea is that x plus 3 is a linear graph, it's always strictly increasing, therefore the maximum value will occur at 4, the minimum value will occur at 2. And let's say we have gx being sine x for any real value. So for any x being an element of the reals. Alright. So you can calculate that the range of g, right, is going to be quite simple, right? It's a sine graph, so it's simply minus 1 and 1 inclusive. From here, right, we can now kind of like see what composite functions exist and what doesn't. Now, if you look at, let's say, arguing whether f gx exists, we note that we have to find that the range of g, which is basically minus 1 and 1, does not, and is not a subset nor equals to the domain of f. Why? The domain of f is 2, 4. The range of g is minus 1, 1. Therefore, if you try to substitute the range of g into f, you notice that you'll be substituting the numbers that are not defined by f. F is only defined by x equals to 2 to x equals to 4, but not x equals to minus 1 to x equals to 1. Although you can put values inside, you won't get any corresponding value. Because of this, fg doesn't exist. However, if you're to look at gfx, what do you notice? Now we have to see whether the range of f is a subset or equals to the domain of g. So we note that the range of f is 5 to 7. The domain of g is basically any real number or simply negative infinity to infinity. And you notice that 5 to 7 is indeed a subset of the real numbers. Alright, and because of that, gfx exists, so gf exists. Alright, now this is the effect on gf. So we now have gfx basically defined by sine x plus 3, right? You just simply substitute every x in the function of g with fx. So we have sine bracket x plus 3. Now the domain of gf is simply 2, 4. Alright, the domain of f. The idea is that now you are substituting fx, and now obviously when you substitute fx, the input will be for fx, and then fx will then be the input of g. That's the idea of composite function. So the input of fx would, the input of gf, which is the domain of gf, will be the input of the substituent or the substitution. Therefore, domain of GF is a domain of F equals to 2 to 4. How about the range of GF? Now the range of GF, right, because it's a sine function, you kind of have to like count. If I'm not mistaken, it'll be sine 5 to sine 7, right? Because sine 5 is like between 3 pi over 2 to 2 pi plus something, all right? So, I mean, I can kind of tell, right, because it's kind of a terrible value to put in, but whatever, all right? So the range of GF, right, is basically the range of, you have to calculate based on the new domain. So if the domain is now 2 to 4, you now have sine 5 to sine 7. So you just find out what is the minimum value and what's the maximum value. For me, I can tell that the minimum value is sine 5 and the maximum value is sine 7, but it does not always happen, all right? So sometimes you can have, like, let's say your composite function is now x minus 6 whole thing square plus 1, then you've got to be a bit careful, okay? So yeah, there we have it, the composite functions and the conditions for it to exist and the subsequent result on our composite function.